Hi there, I'm Joe Pollock from the Nature Conservancy, and we're here in beautiful Dominican Republic on the island of Hispaniola in the Caribbean Sea. We're here today to learn all about corals, what they do for us as people, for the world, for biodiversity, and we're going to learn about what's happening to conserve coral reefs and to restore them so that they can continue to bring benefits to the natural world and to the people that depend upon them. Come with me.
Hi everyone, I'm Jessica Garcia, your host for today's exciting virtual field trip to the Dominican Republic to uncover the secret life of coral reefs. It's made possible with generous support from the Students Rebuild Challenge, a program of the Bezos Family Foundation. We are so excited to have you all joining us today. And because this is a live event, we're going to have a few interactive opportunities with all of you out there today. And that opportunity comes with polling. So if you go to slido.com and enter in the code CORAL, we're going to be able to get results from all of you joining, and you're going to get to see who else is along on this field trip journey with you to the Dominican Republic. Now what's great is for this event, so far, we've had 5,000 schools sign up, which is equated to 150,000 students who are joining you on this adventure today. So our options for the first polling question is, where are you coming from? We want to know. There's so many of you out there, the numbers I've already given you, so let's find out where you're joining us from on this virtual field trip. Now there are a few options. You could be joining from the eastern US, the western US, the midwestern US, the southern US, but also we have students who could be joining from the Caribbean, which is the area that we're going to be exploring today on this adventure to the Dominican Republic. So I'm going to give you a couple seconds to send in your results, and you'll be able to see them live with us at the same time. So far, it's looking like there are a lot of students coming in from the eastern US, but the Midwest and the West are coming up as well. We have some students joining from the Caribbean, which is great because this is a local situation that is going to be affecting directly, but the rest of you are going to have an opportunity to see those connections as well. Oh, the southern US and Midwest are still coming up. Thank you all for joining us today from wherever you're coming from. And you're going to have two other opportunities to send us your feedback, and we're going to see those polls later in the virtual field trip. Are you interested in the ocean? What about the animals in it? Do you like saving the planet from climate change? Then I think you're going to like what we've got in store for you today in the Dominican Republic. The Dominican Republic is in the Caribbean Sea, and it shares the massive island of Hispaniola with the country of Haiti. It's the second largest country in the Caribbean. Cuba happens to be the largest. The Dominican Republic has more than 10 million residents and nearly 800 miles of coastline. It's located in the tropics, which means it lies between the tropics of Cancer and Capricorn. So it has warm temperatures, as well as beautiful ocean, great people, and maybe the coolest part of all, coral reefs. And speaking of coral reefs, we happen to have a real coral scientist here, someone who spends his professional life studying and working with corals. To take us on this amazing exploration under the sea, I'd like to welcome my good friend, Joe Pollock. Joe is the Nature Conservancy's Coral Strategy Director for the Caribbean. Welcome, Joe.
Thanks, Jess, for having me. It's great to be with you. And it's also great to be with all the students who are joining us today.
So some of our audience may think scientists are serious people who don't know how to have any fun. Was it a lot of grueling study in a lab to get to where you are now?
I'm glad you asked that, Jessica. So for all of our friends out there who might be considering a career in science, or who maybe just want to know a little bit more about scientists, we've put together a little bit of a video.
And now it's time for Top 10 Common Myths About Scientists. Coming in at number 10, they're all really old. At number 9, they're all really boring. Number 8, they all wear white lab coats. At number 7, they all work in stuffy labs. Number 6, they like to study animal poop.
Well, that one's actually true.
Number 5, they can do long division in their head.
23. I was gonna say that.
Coming in at number 4, they smell like day-old cheese. Number 3, they all have posters of Jacques Cousteau hanging on their walls.
That one's actually true.
And at number 2, they have 0 musical aptitude. And finally at number 1, they only hang out with other scientists.
Well, if that were true, I wouldn't be hanging out with you guys today.
We're glad you're here. I'm a scientist too. I grew up in Arizona, a desert landscape very different from where we are exploring today. I spent a lot of time at state and local parks, which drove my love for nature and led to me studying biology in college. Now I am a sustainability scientist with the Nature Conservancy, and my team works to help other large organizations make improvements to better the environment. Joe, how did you become a coral scientist?
Jess, I've been in awe of the natural world as long as I can remember. Growing up in the hills and the valleys of West Virginia, I have fond memories of searching for critters in the mountains around my home and generally just marveling at the beauty and the wonder of the natural world. That curiosity led me to study biology in college, where I learned that the natural world is actually far more complicated and far more elegant than I'd ever imagined. Since then, science jobs and fellowships have taken me all around the world. I've had the incredible good fortune to work in Florida, Hawaii, Panama, the Bahamas, Colombia, Australia, and of course the Dominican Republic. Through my work, I've been able to study the species and the ecosystems that fascinate me. I've been able to meet some of the most interesting people in the world and work with them to hopefully provide a more positive future for coral reefs and for the people that depend upon them.
Wow, Joe, it sounds like you have the kind of job that we'd all like to have. We're so lucky to have you as our guide on the field trip to the Dominican Republic. But before we start our virtual travels, if you've joined us for a field trip in the past, you'll remember we have a game we like to play. It's called Nature Spy. We ask you to pay close attention to and keep track of what you see on our trip. Today we're going to see a lot, from ocean sponges to coral reefs to colorful tropical fish. Here's how Nature Spy will work. When you see one of the organisms on the sheet, make a check mark in the box. Pay close attention. There are a lot of interesting looking organisms under the sea. Now it's finally time to head to the Dominican Republic. Are you all ready for an amazing trip? I know I am. Joe, I think we're ready to go.
Awesome. Well, I hope you brought your swimsuits, because we're about to spend a lot of time in the water. Reefs are amazing. They're colorful, they're full of movement and action, and they're home to one of the wildest varieties of life on the planet. They're often also incredibly old. Reefs can take anywhere from 10,000 years to 30 million years to form. That means that even the youngest reefs have been around for almost as long as human civilization. Now, besides the Caribbean, where we're visiting today, coral reefs can be found in the Pacific Ocean, the Indian Ocean, the Red Sea, and the Persian Gulf. What those places have in common is that they all have warm, salty water that corals like, that are between 65 and about 84 degrees Fahrenheit. Reefs also need sunlight to grow, so they prefer clear, shallow water. Coral reefs are really incredibly diverse places. In addition to all of the different types of corals, reefs have a lot of other species living amongst them. Millions, in fact. Now, while reefs take up only 0.1% of the planet's surface, up to 25% of marine organisms live among reefs at some point in their lives. We use the term biodiversity to describe this variety of life that's found on Earth. Why is biodiversity so rich around corals? It's because coral reef ecosystems provide food and protection for both plants and animals. Reefs help people too, but we'll talk a little bit more about that later on. So living within and around a coral reef, you'll find invertebrates, like sea urchins, snails, scallops, clams, squids, octopi, and sponges. You'll also find a lot of really beautiful and colorful fish, like sergeant major fish, anglerfish, grouper, four-eyed butterfly fish, and one really special kind of fish, the parrotfish, which we'll talk more about in a second. Around here, you can also see sea turtles, manatees, and even whales. And we can't forget the predators in these ecosystems. Those include things like sharks, barracudas, snappers, and eels.
We are just beginning on this journey, so I don't want you to think that you have to know all the answers now, but we're going to open up our Slido poll again, And again, you can enter in the code CORAL, and we're gonna have an opportunity for you to test your knowledge and see what you already know going into this virtual field trip when it comes to corals and coral reefs. So you have a few options this time for answering the question. So the question is, what are corals? The possible options are plants, are they animals, are they rocks, or are they a symbiosis between an animal and a plant-like dinoflagellate algae called Symbiodinium that leave behind rock-like skeletons? And because I'm not the expert, I'm going to toss it over to Joe, who can tell us what the right answers might just be.
Okay, well, I am very heartened to see that very few of you put rocks. That is not the right answer. In fact, the correct answer is that funny kind of long symbiosis between the animal and the plant-like algae called Symbiodinium, leaving behind the rock-like skeleton. Let's learn a little bit more about this fun and interesting symbiosis by turning it over to Victor Galvan, who's the research manager at Grupo Punta Cana Foundation.
So corals are animals. They're living, breathing animals like you and the seals and the whales that we see. That they're really tiny, and a lot of times it's hard for humans to see the individual corals. So we constantly assume that they are just a rock, but they're an animal, and in the tissue of the animal, there's an algae that allows them to produce the food that they need just from photosynthesizing energy from the sun. Photosynthesis is just basically converting sun energy into usable food, calories, or food for the corals. And that also helps them create the skeleton. So as the coral's feeding and growing, it's taking in CO2 from the ocean, it's taking in other nutrients, other chemicals, other elements, and that is combining them into this carbonate skeleton that they form. The carbonate skeleton is pretty similar to what human skeleton looks like.
Wow, that is complicated. So the algae lives inside of the coral animal, which leaves behind a skeleton-like rock. Then what is a coral animal, and how is that different from a coral?
That's a good question, Jess. So corals are really complex, which is one of the things that I think makes them so amazing. So a coral animal is also called a coral polyp. They're invertebrates, which means they don't have a backbone, like we mentioned before. And they're also really closely related to jellyfish. In fact, one way to think about a coral is almost like an upside down jellyfish in a skeleton cup. So they have these tentacles that they can use to capture food, but in fact, that's not their main source of food. Corals get most of their energy from the algae that lives as a part of the coral animal. And when we have these two organisms living closely together, so the coral and the algae, we call that a symbiosis. Now, when we talk about coral, we're actually talking about a colony. So that's a colony made up of many thousands, in some cases tens of thousands, of coral polyps living together. And those colonies are what form some of the really beautiful and interesting and intriguing shapes that you might see out on a reef. So let's go to the lab in Punta Cana. We'll go to the Center for Marine Innovation, and I'll show you a little bit more about them. When we talk about coral, we're talking about many different things. We have a staghorn coral that grows in a branching way. We have a brain coral, also known as a massive coral, that builds a mound. We have pillar coral that grows up in a pillar. And we have elkhorn coral, as you can see why they call it that here as well. So coral is what we call a colony. So just like a house is composed of bricks and many of them make up that house, corals are made up of individual polyps living beside each other, communicating with each other, sharing resources, but each individual polyp can do all of the things that a coral needs to survive. So each individual polyp can eat, they can do reproduction, and they grow. Each individual polyp is able to lay down a skeleton layer by layer by layer. One of the ways that I think about it is if you imagine a skyscraper being built level by level by level. So you're gonna build the first floor, then you're gonna move all of your furniture, everything else to the second floor, and just move up level by level by level, abandoning what's below. So the living part of the coral will only be on the first half of an inch, the first couple of centimeters, and everything left behind, everything below, is dead skeleton.
Really? So how much of that skeleton gets left behind?
So it's actually hard to believe, but coral reefs can actually be seen from space. They're that large.
That's crazy considering how tiny coral animals are.
I mean, that's true. The coral animals are small, but it's easier to understand when you think that a reef is made up of millions and millions of these individual coral polyps that have all been growing together for thousands or in some cases millions of years.
Can you talk more about how these polyps work together to form a community?
Sure, yeah. So before I mentioned that the living part of the coral is really just a thin layer on top of the bulk of the coral skeleton. And those corals can actually, the coral polyps can actually communicate with each other throughout that quote unquote skin. So if you go up to a coral and you wave your hand over it, you'll see those polyps starting to retract back into the skeleton. And what's really interesting is you'll see that kind of happen as a wave over the coral colony. And so what's happening there is those coral polyps, they're communicating with each other. They're saying, hey, there's a threat out here, and they're spreading that sort of warning sign throughout the coral colony. So they're communicating with each other, and they can actually share food through that layer of skin as well.
This is a lot of new information for me, and it makes me want to ask a ton more questions, and I can't be the only one. Actually, I think it's about time we take some questions that were submitted by our audience.
Hello, my name is Erico from New Rice's Bilingual School. We know that natural resources are vital to this country's economy. How can preserving or protecting coral reefs help us economically?
So Eric, that's a great question. You can think of coral reefs as really being one of the most valuable natural resources that coastal communities in the tropics have. In the Dominican Republic alone, coral reefs bring in an estimated $1 billion in tourism expenditure, which, as you can imagine, is incredibly valuable for the Dominican Republic economy. If we lose the coral reefs, we're going to lose all sorts of different benefits that they provide, one of which is tourism. So an investment in protecting, conserving, and restoring coral reefs is really an investment in the economic well-being of the Dominican Republic and of tropical locations around the world.
Hi, my name is Seth Clark from Xavier Lower School, Nassau, Bahamas. Tourism is one of our main industries, and I would like to know more about the impact that it has on coral reefs.
So Seth, that's a really great question. So, as you stated, the Bahamas is really reliant on tourism, just like we mentioned the Dominican Republic is in the last question. But your question was, what impacts do tourism have on coral reefs? Some of them can be negative. If you've got people out there kicking their fins and not being careful, they can break corals, they can damage them. If we have a lot of coastal development, that can also be negative. But if tourism is done right, it can actually have a beneficial impact on coral reefs. So a little bit later on in our virtual field trip, we'll be going to Coral Mania, which is an event where tourists are going out and growing corals and planting them. So they're actually having a beneficial impact on the coral reef ecosystem.
Hi, my name is Rachel Bain from Eva Hilton Primary School in New Providence, Bahamas. How does climate change affect our coral reefs?
Another really great question. Thank you, Rachel. Yeah, so climate change is honestly, it's the biggest threat to coral reefs right now. We'll talk about this in much greater detail a little bit later on in the field trip, but the biggest problem is that climate change is raising the ocean seawater temperature. As that temperature increases, that partnership, that symbiosis between the coral and the algae breaks down. The algae are expelled or kicked out of the coral, causing the coral to turn white, to be bleached, which we'll talk about. And because we discussed, they get a lot of their energy from that algal symbiosis that has a really negative impact on corals. And in many cases, if the temperatures aren't brought back down, those corals will die. So climate change is a major, major driver of coral reef decline around the world.
Great questions, everyone. All right, we've talked about corals. Now let's get into why these tiny creatures are so important to animals and people. Let's start with the one special fish you already mentioned, Joe, the parrotfish. What makes them so special?
So just competition for space on coral reefs is intense. You can really think of it as this constant battle for space between corals and weedy algae. Now, once the algae puts down its roots, it's really hard for the coral to compete with that algae to reclaim that space. Fortunately for corals, they have an ally in this battle for space, the parrotfish. Parrotfishes act like a fleet of fishy lawnmowers, eating the algae and keeping the algal lawn in check so that there's still space for new baby corals to settle onto the reef and to begin to grow. One other interesting fact about parrotfishes, when they chomp on algae, they also munch off little bits of rocky reef, and then they get rid of it. Incredibly, some parrotfish species can poop out over 1,000 pounds of sands per year. Maybe that's something worth thinking about the next time you go and dig your toes into the beautiful white sand of a beach like in the Dominican Republic.
So when I go to the beach and stick my toes in the sand, I'm really sticking them in parrotfish poop? Kind of gross, but actually contributing sand for beaches is one of many ways that reefs positively affect our lives. To find out how else coral reefs are vital to a place like the Dominican Republic, we asked some of the local residents.
Tenemos más océano que tierra, por decirlo así, y es por ello que es importante cuidarlo. O sea, en el mar tenemos la mayor cantidad de vida.
We subsist because the coral reef are here. We are an island. When the storm come here, all the pressure of the waves, all the stuff, the coral reef is stopped.
They provide habitat for a lot of species, some of which we eat. They're important also for the economy because they bring tourists in.
Ellos se alberga lo que es mucha vida marina y tienen una gran importancia y un gran impacto a lo que es el medio ambiente marino.
Claro, sin corales no tendríamos playa, no tendríamos buena pesca, se escasean un poco los recursos con el turismo, claro.
So hopefully by now you're starting to understand why coral reefs are so important to the world around us. No matter how far you live from the ocean, it's important to remember that your life is connected to coral reefs in one way or another. For example, by providing homes for fishes, coral reefs contribute a major source of food for over 1 billion people around the world. Coral reefs also support health by providing ingredients for medicines that treat everything from asthma to arthritis to cancer.
Okay, so coral reefs are kind of a big deal. Now we understand how important reefs are. Can we talk about some of the problems that they're experiencing?
So, Jessica, I think it's really important to be realistic about the issues that coral reefs are facing. By now, we've seen that they're beautiful places, we've seen that they have incredible biodiversity, and we've just talked about the importance they have for ecosystem services, including things like coastal protection and supporting fisheries, tourism, and recreation around the world. But coral reefs are in big trouble all around the world. In the Caribbean, more than half of coral reefs have died off in only just the last 30 years. Now that's bad for fish, but it's also bad for the people who rely on reefs in the ways that we just mentioned. Warming temperatures are a big part of the problem. Remember that symbiotic relationship that we discussed between the coral animal and the algae? Even a 1-degree change in water temperature can upset the symbiotic relationship between those two organisms. If the algae gets too hot too fast, they can get stressed out and in turn leave the coral, causing it to lose its color and become what we call bleached. And of course, that means the coral can't get the energy from the sun anymore. Now, corals can live for a little while like this, but if the temperature doesn't decrease in a few weeks, the corals are very likely to die. We're also seeing an increase in coral disease outbreaks, which are related to rising ocean temperatures and also to pollution that washes into the ocean when it rains. This includes things like fertilizers, garden chemicals, and human waste. Hurricanes, which are really common around here, can break pieces of coral off, and warmer temperatures have been contributing to an increase in the number and the intensity of hurricanes. Now, you might know that climate change is caused largely by extra carbon dioxide, or CO2, entering into the atmosphere. A lot of this CO2 gets absorbed by the oceans, and it actually makes the oceans more acidic. It makes it harder in turn for corals to build their skeletons. If you're interested in learning more about that, there's some really cool activities in the teacher's guide that you can check out. Local factors also affect corals. Remember the parrotfish we were talking about? If too many organisms like this parrotfish and other organisms that eat algae on the reefs are harvested by fishers, then the algae can take over and they can harm the corals. Lastly, one thing you should keep in mind if you get the opportunity to visit a reef is that kicking them with your fins or stepping on them can break off pieces of coral just like a hurricane, and also have a really negative effect on reefs.
Okay, so that's a lot of threats that corals are facing. It makes me want to ask, is there anything that can be done to help the corals?
Fortunately, the answer to that question is yes. If we can protect and repair coral reefs, we can save this incredible habitat and the resources that they provide for everyone. And that's exactly what we're doing with our three-part program of monitoring, protection, and restoration. So we monitor the size and the health of coral reefs in order to understand how they're doing around the world and to decide where to focus our conservation and restoration efforts. This work has traditionally been done by divers, but divers can only cover a small area. In fact, it would take about 250 million diver hours to cover just the Caribbean coral reefs only a single time. New technologies can help dramatically expand the speed and the accuracy with which we can monitor corals. We're now using drones that fly above the water, a highly specialized airplane called the Carnegie Airborne Observatory that takes images in infrared and ultraviolet ranges, and an array of hundreds of satellites. And all of these things are mapping the exact same coral reefs at the exact same time. Now, one of the most exciting things coming out of this work is that we can now produce the first ever high-resolution maps of shallow coral reefs throughout the entire Caribbean basin. With these maps, we can tell exactly where coral reefs provide the greatest benefits to humans, for example, by breaking up waves, and we can figure out exactly what impact our work is having on the health of coral reefs, for example, whether they're getting better or not. So through all of this, you might have been wondering why we're here in the Dominican Republic. Well, the monitoring work that you just saw and that of our partners have identified the reefs here as particularly important. And we and our partners are mobilizing an army of volunteers to do something to protect them and to restore them. Now let's see what it takes to restore a coral reef. We're here in beautiful Bayibe, Dominican Republic. I'm here with Rita, the director of Fundamar, who's really been organizing all of the coral mania and associated insanity. Can you tell us a little bit about what we're going to be doing in Coral Mania, what's happening?
The main goal is to transplant as much corals that we can to the reef. This year we have around 50 divers, so we are going to split in 4 teams, in 4 separate boats. Now we have a goal of between 1,000 and 2,000 coral to be transplanted in these 3 days.
So we're going to be going out and we're going to be planting thousands and thousands of corals. Why do we need to do that? Why is it important that we grow up corals and that we replant them onto the reef?
Everybody in the Dominican Republic depends in the tourism sector or in fisheries. It's also employment. It's also the protection that they provide to all the reserves and atolls that we have in all the coast. If we lose the coral reef, we are going to lose the economy of the whole country.
So Rita, through this virtual field trip, we're going to be reaching thousands of classrooms all around the world. If you could deliver one message to the students who were visiting today, what message would you deliver to them?
That corals are amazing. When you start to work on corals, you just love them because all the things that they show to you, and they are amazing animals. In Fundamar, we always say that you need to know about things to love them, and then you are able to protect them. So that's why it's important. You need to learn about corals, so you are going to be able to protect them.
That's a lot of coral and really impressive work. So in that video, we saw coral growing underwater, waiting to be planted. What kind of coral was that, and what is the technique you were using?
So the coral that you saw us transplanting there are called staghorn coral. They're quite rare but incredibly important coral in the Caribbean. Now the technique that you saw there is called fragmentation, and it's where we break off pieces of coral and we replant them somewhere else in the reef where they'll continue to grow up into large coral colonies. Now the coolest thing about this technique is that the coral that's left behind in the nursery continues to grow, and we can keep harvesting from it time and time again. So next, let's take a moment and let's learn about a new technique that could dramatically speed up the way that we grow coral. Now typically coral reefs take an incredibly long time to grow on their own, but we're working with partners to develop new techniques to help speed up their growth and repair processes. And it all starts by growing new coral. Now there's two main methods for growing coral. The first we call traditional fragmentation, and it's really a relatively simple process. We start by growing new healthy corals in a safe environment under the sea. In about 6 months to 1 year, the corals are now big enough that we can fragment or break them off into smaller pieces. You can think of it really just like pruning a plant that might be in your backyard. We now take these coral fragments that we've harvested and we plant them in the reefs so that they can continue to grow up. But there's another, even faster way for us to grow new coral, and it's called microfragmentation. It's similar to traditional fragmentation, but this time we cut the corals into really small pieces, no bigger than your fingertip. Now they're too small to put back into the ocean straight away, so first we grow them in the lab. When corals are this tiny, really the only thing that they focus on is growing. They don't use their energy for anything else for about the next 3 months, and this is how we can grow them so much faster, in fact cutting the growing time in half. After a while, when the corals grow big enough, we'll move them out of the lab and into the ocean. We can then attach them in the same way we did with the other corals. And that's how we're using science to help rebuild the reef.
Now that we know what scientists and local organizations are doing to help corals, is there anything our students watching today can do to help the corals survive and even thrive?
Yeah, Jess, I mean, there's a lot of work to do to keep our oceans healthy and protect our reefs, and it's going to take an army of volunteers and interested persons to do so. So here's just a few ideas of what you out there can do to help protect coral reefs. You can cut down on your carbon emissions by walking, biking, or carpooling rather than going in a car. By reducing the amount of carbon going into the atmosphere, we're going to be removing those dramatic increases in water temperature that we see can cause coral bleaching. You can also use less plastic. Plastic pollution is a problem globally. It's a huge problem in the ocean, and it's a really big problem on coral reefs where we see little pieces of plastic trash getting caught up on coral colonies, opening them up, causing diseases, which as we know is really, really bad for coral. You can eat more sustainable seafood. So that includes removing things like parrotfish from your diet, which are incredibly important, as we saw, for helping in that battle, corals battle for space with macroalgae. And finally, you can write to your government officials and tell them to support marine conservation and the establishment of protected areas. It's going to take people from governments to individual action to be able to address this global issue. And it's going to take actions both small and large to do so.
Joe has given us a lot of really incredible ideas for how we can reduce our carbon footprint, how we can reduce our environmental impacts, and ultimately how all of this is going to help us reduce the negative impacts on coral reefs so that all of us can make sure that they stay beautiful and vibrant for many years to come. But now, because you're all joining us, we really want to know how you are going to make some changes today and moving forward to reduce your impact. So we're going to go to Slido for one last time and find out from all of you what impacts and changes you're willing to make. So we have some options up here. So we can plant a tree, like this little guy right here. You can turn off lights when you leave a room, any room. You can make sure to be using reusable water bottles, whatever kind, but you should always be using those. You can also pick up trash in your community, around your neighborhood, anywhere that you go. And also learn, as Joe mentioned earlier, you can learn to find out which fish are sustainable for you and your family to eat. Now, me personally, I know it is a beautiful day outside, so I'm gonna go ahead and take my bike home rather than a car. Joe, I know there are a lot of questions out there from the students on our virtual field trip. Would you mind answering a few more?
Of course.
So this question comes from Soyson, California. Are coral reefs alive? And if so, can they see and hear?
Great question. So corals are alive. It's pretty amazing to think that something that can be seen from space is created by a living organism that's almost microscopic in some cases. The other questions are, can they see and can they hear? Corals don't have eyes, but in fact they can see in a sense. They have what we call photoreceptors, where they can sense different colors. And although we didn't really get into it on this virtual field trip, there's a thing called mass coral spawning, where corals reproduce at the exact same time, even if they're thousands of miles away. And the way that they do that is by sensing light put off by the moon. So they can see. They can also hear. There's been some really interesting research that shows that coral babies or coral larvae, which are actually a swimming stage of coral when they're very small, are actually attracted to the sounds of coral reefs. So the sounds of snapping shrimp and other things. Those baby corals are attracted to that reef where they'll then settle down and grow up into adult corals.
That was new information to me, Joe. This next question comes from Citrus Cove Elementary, which is located in Boynton Beach, Florida. How are islands like the Florida Keys made out of coral?
Great question. So yeah, the Florida Keys are the remnants of ancient reefs. So the way that that works is about 100,000 years ago, the sea level was a fair bit higher than it is now. It had thriving coral reefs in that area that grew up to right about where that sea level was. Then during the last ice age, the sea level dropped, leaving behind those coral skeletons, which over time became fossilized and created the landmass that we now know as the Florida Keys.
Joe, I think I'm learning more than the students are today. Our next question comes from Retta Brown Elementary in El Dorado, Arkansas. How can you tell if a coral is alive or not?
I'm really glad that, that the student asked this question. It's a common question and a common problem. So what you see here, this is a live coral colony. So you've got the coral tissue, which is giving you those tentacles. You've got the brown specks or brown dots inside. Those are the microscopic algae. So this is a happy, healthy coral. If we get increased water temperature, the algae will leave. You still have the coral tissue left behind, but you're going to be able to see through it to the white skeleton. Now, over time, if that algae doesn't come back in, you're going to get coral death. So here you see white skeleton, but if I look close up on that skeleton, I'm not going to see any coral tissue. I now know that that coral's dead. And what's really dramatic is that you'll only see that dead white skeleton for about a week, and then you'll get overgrowth by these kind of weedy algae that grow over top of it, turn it into like a muted, boring, dead sort of look. And really that's how you know whether the coral's alive or not, by whether there's that coral tissue there or not.
This next question is from South Grant Elementary in Dry Prong, Louisiana. Are you seeing effects of plastics in the water?
Unfortunately, we are. So some estimates have said that 10 billion pounds of plastic enter into the ocean every single year. So that's a problem for all different marine environments, but it's a particular problem for coral reefs. A friend of mine, Dr. Jolie Lamb, did some research that found that when corals are in contact with plastic, they are 20 times more likely to get sick. So those corals touch the plastic rips open their skin, and it allows pathogens to enter, which is really quite bad for them. So yeah, unfortunately, plastics in the oceans are a big problem, and they're a big problem for coral reefs.
Okay. So from Big Rock Elementary in Chesaning, Michigan, how do you know how old a coral is?
So a lot of people will know about tree rings, right? So that you can age a tree by how many rings it's built up over the years. Not a lot of people know that you can actually age a coral in similar ways. So as we saw previously in this virtual field trip, corals lay down their skeleton layer by layer by layer over time, and the density, or really kind of the color of those layers changes by the kind of environment the coral's living in. So when it's warmer in the summer, they'll lay down different kinds of rings than they do in the winter. And you can use those layers of rings to be able to tell how old a coral is. And one thing that's actually even more interesting is that because those layers are related to the temperature and other environmental conditions, you can actually use a coral skeleton or a coral core to look back in time and be able to know what the environmental conditions like the temperature and rainfall were like when that coral was laying down those skeleton layers years, decades, or even centuries ago.
Very interesting. So this next question comes from Hampton Elementary School in Rochester Hills, Michigan. If students want to become scientists that study coral reef ecosystems someday, what should they be focused on in 3rd, 4th, and 5th grade?
I love that you asked that question. I would say stay curious and stay inquisitive. I mean, science is all about questioning assumptions, digging apart a problem, and really just finding out as much as you possibly can. Of course, you're going to have to focus and you're going to have to work hard in your math and science classes, but you know, if you see those rather than just being work as being really an opportunity to learn about the immensely interesting and immensely complicated world around us, that won't feel like work. I know that I enjoyed school. I mean, the crazy thing is that it's been more than a decade since I left high school, and I'm still going out, questioning things, learning about the world around me. The coolest thing is that now it's my job.
I agree 100%. Well, I'd love for us to hang out some more with you, Joe, but I'm afraid we're almost out of time. I want to thank you so much for sharing your knowledge of coral reefs, as well as the work you're doing to save them, along with the divers and crew.
And Jess, I'd like to thank you for hosting this event, and I'd like to give a heartfelt thank you to all of the students who joined us today. I'd also like to take this opportunity to thank all of our partners, without whom we couldn't do any of this work. I'd like to give a specific thanks to our partners at Fundamar, Grupo Punta Cana Foundation, and Red Arrecifal Dominicana, and to all of the divers and everyone else who joined us to make Coralmania a huge success.
I also want to thank all of the students and teachers out there who have participated today. Please spread the word about what everyone can do to help the environment and assist Joe in making our coral reefs healthy and vibrant again. Be sure to check out the teacher's guide on our website for more information and activities related to coral reefs. Finally, our deepest thanks to the Students Rebuild Challenge, a program of the Bezos Family Foundation, for supporting this virtual field trip and some of the work taking place in the Dominican Republic.
Gracias, Fundación Familia Bezos.
Thanks again for traveling to the Dominican Republic with us today. We hope you learned some new things and enjoyed the virtual field trip. Bye for now. Ciao.